Well, good morning, good evening, good afternoon, wherever you join us from around the world. Welcome back to Creation Conversations, where we have some of the team, at least. We've got Glenn and Diane and Craig and myself, with an absence. There we are. Absence of John, because he is still having ongoing issues with his wife. So do pray for Anne, who's carrying on with the problem of dementia, which we've spoken about on the program before. So pray for John, that especially as he gets a little bit of rest. We've also got Steve with us. Now, you might remember Steve featured on Creation Conversations a few weeks back when we were live on our convention broadcast, and we also shared a message that Steve had taught us that morning as part of devotion. So Steve is coming on board the Creation Research team to sort of basically help out in the background primarily, right? Interact with you guys, do some of the question asking rather, and so on and so forth, as well as contribute as the rest of the team. So continue to pray and support Creation Research as we build up the Creation Conversations team and get some other people involved as well. But for today, Steve is sort of going to be interacting, but a little bit in the background, just sort of seeing how things go and trying to wrap his head around the software, which I've been doing this for 3 years, and I still haven't quite got it yet. So there we go. We're going to kick off tonight, however, with a little article that Steve actually found for us earlier, because I do think it is quite funny. Let's pull it up here. Here we go. Some small dinosaurs flap their feathers to scare prey and to catch a meal. Now, one of you made a comment about this being a turkey earlier. Who was that? Was that you, Glenn?
That was me.
Ugly-looking turkey, eh?
Yes.
But Steve, you found this report, this news report. What was the sort of the crux of the issue? Because as somebody rightly pointed out when we pulled this up, it was sort of, when on earth have we observed small dinosaurs flapping their feathers to scare prey and to catch a meal, as the headline actually suggests. So, what are the researchers behind this actually doing?
Yeah, well, if you read through the article, I just read through it sort of briefly, but yeah, I mean, it comes down to basically simulation. They created a robot and put some scenarios through the robot based on what they see in the world today, what they observe in the world today, different creatures and different preys, and yeah, so what they've observed is not a dinosaur, but a robot.
Now, Diane, you made an important point about this robot being designed. What was that?
Well, they have created something and then they have used it to confirm their belief in evolution, which is supposed to be a process that doesn't involve creation. I think there's an inconsistency in the logic there.
I think one of the things that grabbed my attention initially was, yeah, they had the title, but also just the assumption, the notion that dinosaurs had feathers, and right at the beginning of the article, dinosaurs and birds seem to be the same, and they had feathers, and we found dinosaurs with feathers. It's all through the article.
It references Northeast China in 1996, which is interesting because that's been proven to be fabricated fraud.
Yeah. It also writes off Archaeopteryx as being a dinosaur. It's a statement that's basically admitting Archaeopteryx isn't a dinosaur, it's a bird. So, good, yeah. But we know why they became extinct now, because they're so ugly.
So what the headline should say, rather than saying small dinosaurs flap their wings to scare prey, it's engineers create robot which flaps wings theoretically. So it doesn't sound quite as
and it scared them.
Yeah. Anyway, we've got a few updates for you and a few different programs for you tonight as we go through. So as always, remember to ask your questions as we go. The queue and your question helps us to find it a lot easier when we do come to our designated Q&A session a little bit later. But if you remember from last week, we started going through some of Glenn's road trip that he did over to the sort of the north and the western side of the United States. Fossil fish catastrophically buried for sure. And we're going to carry on with that journey because Glenn didn't stop there. He carried on. You went down to the Grand Canyon and all sorts. So there was some rather amazing discoveries and some real, well, God really provided quite abundantly with some of the research. So we're going to go on to this sort of research trip part 2 from Glenn, and as always we'll go through some of it and then have some breaks where we can stop and discuss and chat about some of the different findings and some of the different things that happened along the way. So Glenn, if you want to pull up your slides for us now.
Yeah.
And
first, before I do, I'll just remind you I showed you this last week, and Joe's going to talk about this. This is what we're going to talk about. We were able to make a cast of dinosaur tracks. And so I'm going to talk about dinosaur tracks, and then Joe's going to talk about making casts. So let me call it up. Right there. All right. Should be started.
It's up on the screen. So Glenn, it's over to you.
All right. So we went into Arizona, and there's a place that's well known. It's not one of the most famous places in America for it. But it's well known because it's on Navajo reservation, and it actually extends over into the Hopi area, and it's the Mauna Ave. That's a name for the geologic formation, or Moenkopi, which is the Hopi Indians section of the dinosaur tracks. And they believe this is from the early Jurassic period, about 200 million years ago, but as we've talked about before, that Jurassic doesn't mean time. It actually means that it's similar to the Jura Mountains. The same rocks are found in the Jura Mountains. And these tracks are in a limestone mud, and then that's been buried and covered up. Over the top of it is these red sandstones. All right. So here's just one of the tracks. And hold up. And one of the things about these tracks, there's lots of different ones. And one of the things that scientists that have looked at it says that it's really not possible to determine the specific types of dinosaurs. And we're going to talk a little bit about that. But they weren't all the same. But there are some quite nice dinosaur tracks in there. Let's see. Why is it not going down? So I wanted to identify the tracks. So I started looking up different guides to guide me into identifying the tracks. The problem is that you get these field guides and they don't agree. If you will just look at number 3 over here, the T-Rex, those two look fairly similar. But when you look at number 4 here, it doesn't look anything like number 4 over here. 7 here doesn't look anything like 7 here. They don't agree on what these tracks look like. So it makes it difficult if all you've got is just the track to go by. One of the interesting things, though, is that you have to hire a guide when you go onto this Navajo property. And we get out there and we're seeing these tracks, and the guide says, "Oh, yes, these are velociraptor tracks." I'm sorry, they're not velociraptor tracks. In Hollywood, yes, the velociraptor is 8 feet tall, but in reality, it's like that turkey that Steve showed.
As well as the fact that, to my knowledge, I think I'm correct in saying this, that Velociraptor has never been found in any deposit in the United States.
Yes.
It's also, these are supposed to be Jurassic rocks, and Velociraptor is a Cretaceous dinosaur. So there's multiple problems with that interpretation.
But they're going to tell you whatever you want to see, because there were other formations in the rocks, and they said, these are bones, and you look at it and go, no, that's just iron nodules. And I've heard from others that they'll say, well, this is an egg, a dinosaur egg. And it's like, no, that's just another unusual formation, an iron nodule. But the point being that it's very difficult. Nobody was there to see these tracks laid, and all we have are the bones. And so my question to those following this is, what creature has this bone structure? And what do you think its footprint looks like? I mean, you can see the toes, it's on its toes. Well, there's its print. Now, would you put those toes with that print? Or what kind of creature makes that print? Well, one that's got a lot of flesh around it that actually has a padding and it walks on its toes. Now, what creature walks on its toes but has a lot of padding? Well, if I show you that picture, you might be able to get it. And that's right, it's an elephant. So you're going to have to go from that bone structure of fossils to figuring out what creature that was. You're going to have a difficult time. And that's part of the problems with these. Yet, when you look at this formation, they've got numerous different creatures that they, quote, have identified from the footprints. But I think for many of these, it's just a guess. So what we found was this.
Can we just pause you for a second there, Glenn? I think that's a good
Yes.
time, because what you've got there then is a bunch of footprints. It's very difficult to identify creatures from footprints, not just because it depends on how the footprints are preserved, but also how the footprints have been treated after they've been exposed, how they've been eroded away, and so on and so forth. Like, I know footprints in the UK, right? Which when I first went to see beautiful, great, big, clear dinosaur footprints in the actual mud, and now I know where they are because I saw them when they were good, but they're pretty much disappeared now and eroded away, and they don't look like footprints that much at all. But you've also said this little interesting thing now, not to blame the guide per se, but he was really selling a story to you, a story of Velociraptor, right? A famous, great big theropod giant dinosaur, famous in the Hollywood movies, and yet everything about what we know about Velociraptor tells us that they couldn't possibly be Velociraptor footprints. The size is wrong, the deposit is wrong, the rock type is wrong, right? And so even the location is wrong.
Yeah.
So not only have you got the issue of the difficulties in finding a footprint or an identification rather for footprint, you've also got an issue with a story that is trying to be sold to you. And it isn't just the millions of years in evolution. It can sometimes just be what brings the tourists in. Now, if you remember, I think it was about 5 or 6 weeks back, we did a two-part program, similar to what we're doing with Glenn now, a two-part program with Craig on his travels up through Australia. And Craig, you visited one particular area, Winton and that sort of area, where there was also a story being sold, a story that's become famous even around the world, because there's casts of these footprints in the Natural History Museum in London where they're also being sold a story. So maybe if we come over to you now for a minute, just to reiterate this and remind people what these footprints that were found in Australia were.
You want me to stop sharing?
You can carry on sharing. You can come back to us for a minute, or it's up to you. I've got it all up on full screen.
So the tracks that you're referring to, Joseph, are the Winton tracks. There's two lots of tracks that are well known up in that area. One's called the Lark Quarry dinosaur tracks, which are about 100 kilometres in a southerly direction from Winton. The other one's only about 20 kilometres out of Winton at the Age of Dinosaurs Museum. The one at the Age of Dinosaurs Museum have actually been transported there. They found them in another location and they cut each slab out. It's quite an extensive sort of site that they've taken up to the museum, and I've got it in a big indoor building. I've got a picture there if you want to.
I'll pop it up on the screen. There you go. Yep.
Nice.
Yeah, so there's the indoor museum at the Age of Dinosaurs Museum, and each part of that they've taken up there. Did you want me to go through some of the other slide
Yeah,
as
go
well.
for it. Yeah. I do think it's
Yeah.
good to remind people that there's this kind of story that's being sold, even in professional museums, right? We're not just talking about local guides that actually sell a story that isn't true. So just run us down through that.
Well, this shows you how important they are to people, because they've literally built this buildings, purpose built to house these tracks, which they've individually cut out in little bits and pieces and then re-put them together like a jigsaw puzzle. This is one of the dinosaur depictions that they find in these tracks, a big sauropod, and that's the tracks that they leave. A little bit like what Glenn was just sharing, actually, that they are toed creatures, but they leave these sorts of tracks, so they're not leaving specific toe marks. And there was other little dinosaurs going in different directions, and this is a footprint of one of them there, and that's a model depiction of those dinosaurs. So the sauropod, we have shared this in Creation Conversations when I went through my trip, but we'll just quickly recap that. So the big sauropods heading in that direction, the smaller ones are heading in the opposite direction, and they don't call it a stampede, unlike the Lark Quarry ones, which we'll get to just in a second, because the big sauropods is a herbivore, doesn't eat the other dinosaurs, so they don't regard it as a stampede. That little mark there seems innocuous. By the way, you can see all the little fragments of the stone there of where they've cut them and taken them up to be on site, because that's meant to save them weathering and wearing out so that people can't study them anymore. Well, that's a lungfish, and the guide said, well, it's just amazing. How do we know that they're lungfish 95 million years later? Because 95 million years later, lungfish are still making the same marks. So they haven't changed at all. And I think I'm correct, and I'm happy to be corrected by one of our esteemed colleagues here, but that's the turtle. There's turtles and crocodiles on site there, and I think that one was the turtle marks. So there's certainly been water involved, because you've got turtles, and you also had crocs there. This is the actual Lark Quarry one, the one that's about 100 or so kilometres south of Winton. And these ones are actually in situ. So they built the building around where the dinosaur tracks were found. And so you can see they've left the overlying sandstone layer there. That's so that in the future they can dig more back and find fresh tracks, which they're certain are under there. But the actual dinosaur tracks are on a mudstone layer underneath them. And in this case, it is called a stampede because you've got a three-toed carnosaur, they call it. But I think it's a bit like what Glenn was just saying. They can't be 100% certain, except they just fall back to the dinosaurs that have been found in the general region. In this case, it's a similar thing. Big dinosaur going one way, smaller ones going the other way. But the storytelling here is that it is a stampede because the carnosaur was clearly wanting to eat something, and these smaller dinosaurs were trying to get away from it. And I asked the guide, well, how do you know that? How can you be certain that that is what they were running from? And he said, well, you can't be, basically. Those big drag marks there are logs. And when we pressed him, he said you can't be sure what they were running from. That's the storytelling. That's the selling of their product. They want people to travel at 100 kilometres out of Winton, which is a fairly remote location in Western Queensland anyway, to come to their attraction to help fund their research and fund other things that they're doing there. The drag marks, the crocs, the lungfish, turtles, they're all indications that water was involved. In fact, some experts say that these dinosaurs were actually swimming. They're actually reaching down with their feet to try and get to the ground. But that's it. That's our recap. Joe, come back.
Yeah.
To Glenn.
And there's been a rather groundbreaking paper that was published, effectively detailing the fact that these footprints are not showing small herbivores running away from large carnivores, but they're both actually herbivores, these dinosaurs that are represented there. And when John pressed the museum guide or owner director, they not only admitted that they knew about the paper and had read the paper, but the comment was, this story sells so well, right? People actually come and see it because you get the impression of the Jurassic Park, great big giant dinosaur chasing the small ones, ripping them apart, carnage and all. But even aside from that story, you look at the actual evidence that you're seeing there, it paints a very different story to the one that they show of millions of years of slow evolution and slow burial, because you have land dinosaurs, you've got fish, right? Lungfish, even though they lungfish, which are still alive today, can sort of come out of the water for short periods of time and still survive. They are still marine creatures. They're still aquatic creatures. So you've got aquatic creatures, you've got terrestrial creatures, the dinosaurs, you've got logs, trees that have been ripped up and stripped of their branches and dragged along in flowing water. So you're clearly looking at very large flood evidence for sure, which doesn't really fit in with the story that they tell you. So it is worth challenging the story sometimes and taking a bit of a step back and going, well, what does the evidence actually show? It's a bit like the story with our feathered dinosaurs earlier, right? That flapped and scared the prey. Well, let's take a step back and actually find what's underlying the story. And the story is, well, it's all based off of some robots that were programmed to do it in the first place. So, question as you go, basically.
Yeah.
All right, Glenn, back to you. Let's carry on with your report. I'll pull your slides up now.
Yeah, let me see if I can get back into it. Okay. So we went there in hopes of making casts. And when we first walked up, I asked, well, I woke him up first and then asked him if we could make casts. And the young Navajo gentleman said, no, it's against their laws. And they could get fined or arrested if they let us. And they said that people used to make casts in the past, but they damaged them. So they can't make casts. Well, we came prepared for that. So we made a lot of measurements. We measured even distances between prints, which for the large tracks would be about 4 feet. You're talking 100 to 120 centimeters is what they would be. And we measured, the various ones. And we also looked at their directions. And what you find is that you get the tracks are in all different directions. They promote it as a migration, but these are moving in every possible direction. And it's not just that, okay, large ones are going in one direction, small ones going in the other. No, they're going all over the place, as you can see. You can see this is a medium-sized one right in here that's going off at an angle. They're just all directions. And like I said, we found a wide variety of track shapes, track sizes. We measured the depth of these. Oftentimes, the toes would be the deepest part, and which is often an indication that they were in water and they're trying to grip and push off the bottom. And so it was just quite interesting. But what was also interesting was the day before we went hiking right there in the area, and we were hiking through a wash that the day before that had received rains. And so that morning we had a guy that passed us up, and we could follow him because we could follow him every time he went across the wash because of his tracks in the mud. But later on that morning, by the time we're coming out, this is a desert environment. It's already dried up and you're not leaving tracks. You could walk right across that. So, I think that's pretty typical. How do you get these tracks to form? They have to be made in fresh, wet sediment before it dries, and then it has to be covered up without washing away and without rains on it. And so all that has to happen over a very short period of time. So all these tracks have to be laid down over a very short period of time. And by the way, this limestone, they say they find ammonites and other of the sea creatures in this same layer with the tracks. So this is just our observations, that it's a mixture of shapes and sizes. So it's a mixture of different types of creatures, and they're going in different directions. They're not migrating, and their toes are often deeper than the pad. So it's, to me, it's a clear indication it's not a mass migration, but a mass escape during a flood is what it looks like to me. But as I said, we had a great time. It was really good. It was interesting, but we didn't make any cast. And the next day, we went on and did our hiking, seeing some beautiful, incredible places, the Antelope Slot Canyon. And I'll just say that the next day after that, we were to leave the area, having not made any cast. And overnight, I just kept being woken up saying, go back, go back. Well, the next morning when we got up, I asked my wife, and we had two ladies from our church that were with us, and they were like, yeah, you feel like God's saying we need to go back, let's go back. And I can tell you, one of the ladies in our group did not want to go back because it really disturbed her to see just how poor the Navajos are. It just kind of broke her heart. So we drove back, and we left the two ladies in our RV. Ruby and I got in the Jeep, and we started driving around, and we found a man there. And we asked him, well, first we found a lady, and she looked pretty respectable. And we asked her, hey, do you know a place where we can make tracks? And she said, come talk to my brother. So we went over there, and I told him, I'm a retired scientist. I work with creation research. I'd like to make tracks. And he says, no, that's against the law. And then he stopped and he says, but I know a secret place. So we followed him. And we followed him for about 40 minutes. He took us way off. I have no idea where we were at, but we were a long ways away. And he took us to a place, and it was actually up on this rise. Now, down here in the bottom looks to me to be the same formation in the same layer that the previous tracks were in, even though that was miles away. But he took us up on that rise, and there were 3 tracks, really nice tracks in a row. So we picked out one, and we made our cast. Now, I put some plastic down because he was very concerned about us destroying it. So I put plastic down. I didn't know how that was going to turn out. But while it was drying, I just turned and asked him, I said, can I ask you a personal question? And he says, yes. And I said, do you know who Jesus Christ is? And he says, yes, he's my Lord and Savior. And then he tells us that the lady we met, she leads their Bible study. I just found it interesting that God had a plan, and he sent us to find 2 Navajos who were Christians and sent us back there to ask them if we could make tracks. And he knew a place where we wouldn't get in trouble. So it's just interesting how God works. So we took these back. We had to remove the plastic, and then it left some little rivets in it, but we just took a little plaster and just smoothed it out. Just took a little water and smoothed it out. And we have some nice casts that now Joe's going to show us how to make casts from. Before I go on, this kind of comes up. This place isn't unusual. There are these dinosaur tracks all over the USA, and they pretty much cover all the USA from the Northeast all the way up to Alaska. There are many, many of these locations, and some of them are the same way. This is the famous one in Glen Rose, Texas. You've got tracks going that way and tracks going this way. This is in New Mexico. This is up in Connecticut. Tracks going in all different directions. Here, this one's in Colorado. So this isn't some unusual formation. This is a common formation. And Joe, y'all may want to talk some more about that. But just to conclude, finish up with what I saw, I'm wondering, how do you explain the dinosaur tracks when there's locations all over the world, each with hundreds to thousands of tracks, and the tracks are going in all directions, and they're typically laid down in an ocean sediment, and then they're covered by laterally flowing sediment. Are we producing these types of geologic features today? I don't think so. So with that, I will end. I've stopped sharing and go back to you.
So a couple of quick comments just from me, and then third open to the rest of the team. The point that Glenn made at the end is a really important one, right? We are dealing with tracks that are found not just in one location, but across basically continental North America, right? You can trace them all the way up into Canada. You can trace them up into Alaska, down into South America as well. There's famous ones in Patagonia and the place like, right? You can come over to the UK. There are over 400 known dinosaur track sites just in the UK, and we're a very small countries, very small island, one of the most studied geologically in the world, but that's partly why so many have been uncovered, right, and found, and new ones are being uncovered and found all the time. You can do the same across France, right? In fact, I've got some dinosaur footprints from France just over there to see if I can angle it right. Anyway, I'll pull some of them over in a minute while the others are talking, but you can trace these footprints across the entire world, and they're in the same major layers, right? So rather than it being just a small deposit or a small local flood or a small catastrophic deposit like you see in some things, you are dealing with a deposit that covers most of the world. So the Jurassic goes across the world, the Cretaceous goes across the world, the Triassic goes across the world, and it's the same major sequences that you find in the USA and Canada, in the UK, and on, right? So you can come to the Jurassic Coast. It's the famous Jurassic Coast. You find dinosaur footprints in the Jurassic Coast. You find dinosaur footprints in the Jurassic rocks in the UK, just like the ones that you find over in the USA and over in Australia, right? You can go to Cretaceous deposits, and it's exactly the same story. So you're not just dealing with a small localized catastrophe or a small localized flood, because if you go to places like, and explore places like Winton, where Craig was showing, right, the evidence of a flooding environment is very clear. It's the same as the one that Glenn was looking at, right, with the ammonites. Whenever you have deep sea creatures and land animals buried together, you have evidence of a flood. But when you find them in the same rock layers, evidence of a flood, and this flood going around the world, you're looking at a much, much bigger flood than a local flood. You're looking at a much, much bigger catastrophe than a localized catastrophe. You're looking at a global flood. So don't be surprised that the evidence, as recorded in the scriptures of a global flood, really is very strong when you get out into the real world and actually do some digging. Okay, so moving on from that, then, has anybody else got any comments and stuff before I talk about perhaps some casting sort of techniques, and perhaps we have some questions?
Well, I guess one of the comments we could make is that there are some other tracks of other animals that are found as well. It's not just dinosaurs that are found around the place. That they're the popular ones, the ones that people want to cut up and move to museums and things like that. But we do find some others, and there's one really well-known one that where they found a bird that's supposed to be found in rocks 60 million years before birds were about. So that's really throwing some confusion into the mix. And in fact, the writer of the article says that it could rewrite evolution.
Yeah. And we find them in Tennessee. Now, I haven't found any, but I keep having people come up to me telling me, oh, yes, we've seen the tracks in the limestone in the bottom of the creeks. And I do have one sample from a little bit further west from here at Carthage in the limestone that John collected, which looks like bird tracks to me, and who knows exactly what it is. But we do find these tracks in this area as well.
Yeah, I've actually got a picture of that. If you want to pull that up, Joe. Sorry, is that? Yeah, have you got that?
Yep, there we go.
There we go. Geologists found ancient bird footprints that are 60 million years too early. Some Popular Mechanics, an article in Popular Mechanics.
It's a bit like, and I can't remember the details, but I remember it was something like they found beehives like 40 million years before flowers had evolved, supposedly. And so it's a bit like, what were the bees surviving on for 30, 40 million years before? Yeah. Anyway,
Dinosaur dung or something.
probably yeah. But there we go. Right. Any other comments before I pull up a few slides about casting and some of the plans that we want to do? While I'm just pulling up some slides here, let's take those down.
Joe, did you want to go to some questions? We've got one question that we actually addressed during the talk, but
yeah, let me just pull up a couple of quick pictures here, just very quickly, if it works. There we are, and then we'll go to some questions after this. So, Glenn mentioned me helping out with some casting and so on and so forth. Well, you can see here, a few years ago, we got to go and spend some time with long-time creation research friend Joe Taylor. Joe was basically a world expert, genius level really when it came to casting, and so he specialized in using various latex techniques to be able to take casts, and where you'd normally use latex on really fine and delicate type things, so you'd be doing it on, say, he used to do a lot of skulls and stuff that he used to do casting using latex and building up into what we call a mother mold and the like. Joe would actually do entire dinosaur trackways using the latex, and he developed techniques which meant that you could cast entire trackways in just a matter of hours. Now, this was quite important, particularly when you found that a number of trackways are sort of either in coastal areas, right, where you have to work very quickly as the tide is out, or even over the course of sometimes a day, because you have to wait until the river gets low enough to be able to expose it and take the cast. And this was one particular trackway of dinosaur footprints that was based out in Texas, where again it was where the river had gone really low, and he managed to take the whole cast, the whole trackway basically, in just a matter of hours. And so he developed this technique to really quickly do the cast with latex. And the great thing is, rather than just like Glenn did with sheets and stuff, you got really fine details without actually damaging the fossil at all, because the whole of the latex lifts up off of the fossil, and then when you take it back, and then it's a bit more work back at the lab basically, and the workshop, which is what we're doing here. We're building up that mother mold around the latex mold, so we're making a strong, sturdy kind of concretion, and using plaster of Paris and all sorts. You get your hands in, get dirty, to basically build up a really strong, sturdy stand for it, which is when you can then go on and make casts. So you're basically reverse engineering, if you like, your cast, right? Glenn has taken a 3D cast of the footprint, which is a mold footprint where the dinosaur actually walked. So you get a 3D cast, and then basically what you need to do with that is effectively use that, and it's not quite repress it into clay and kind of form it, but you need to actually take a cast of that, so you've got then something which you can fill and off you go, right? So you're actually producing something which you can make casts of, can make molds of, and off you go. So we will get around to that eventually. It's a little bit of a complex, it's a long-winded process to get it, but it's well worth it once you have it all in place. So either we'll try and instruct Glenn over the internet, or we'll try and perhaps do it next time I come over to the States, and we can make a little bit of a film feature of it and show people how we're doing it and so on and so forth. But it is quite fun to kind of work on some of these casts and things. Okay, let's indeed run into some questions and have a bit of a look and see what we've got so far. We've got a couple of thank yous, I think, as well. So let me just, in fact, Steve, do you want to pull up a thank you or two if there is?
Yeah, we just have one thank you there from Fiorella Clark. It's a super sticker of with 2 Swiss francs. Thank you very much. We've got a pear character turning around, waving his hand, saying, "Hey, you," while lowering his glasses.
Yeah.
I don't think
A
you
little
need
explanation, because I had to explain this to Steve as well. In case you're new here, what happens is on YouTube, when you do a super thanks or a super chat, right, when you donate us money, it shows you a lovely character. We don't get that character in our software, and so we have to read out a hilarious AI recognized thing. So are you going to act it out for us, Steve? There we go. Lovely.
Unfortunately, I haven't got my glasses on. So.
All right. What about a couple of questions then? Let's see what we've got there. I saw one earlier
There's
about
one question about about tracks and elephant tracks. That's quite relevant at the moment?
Go for it. Yeah.
So this one from Shuggy War here. We can observe elephant footprints and examine their bone structure today. How certain are we of the fossil footprints of extinct animals? Are there ways to determine their foot shape?
Would you like me to go back to the talk? I think the person missed that part of the talk.
Yeah, maybe just pull up a quick slide just to reiterate the fact that I've frozen a little bit, so I don't know how well you can hear me. But yeah, it's probably worth going back to the slide just to make that point that we did bring that up. Let's bring it up here.
Yeah.
There we go.
All right. I'm back to sharing and
go for it.
All right. So yeah, this was the point that I made, because that is a very good question. Here is bone structures of a creature, and we would have to think about what type of print that would leave. You would probably see 5 toes, and these being long toes in the mud. But in fact, this is the actual print, because that bone structure is got a lot of flesh around it, and it's an elephant print. So the elephants walk on their toes, but that's not a problem because of the muscles and the flesh around it. And this would be actually the print that they leave. Nothing at all like their bone structure. So when we're basing footprints off of what we retrieve in the way of fossils, it can be very misleading. And I started that off by just comparing some of the field guides to identify. They don't agree on what the various dinosaur prints would look like, because we weren't there. We don't know. So with that, Joe, we can go back.
And I don't think we tend to find the footprints right near the bones of a particular dinosaur. They always seem to be quite remote from each other.
And they also, as a general rule, there are exceptions obviously, but as a general rule, you almost always find the dinosaur fossils at least a layer or two above where the footprints are. It's almost as if the dinosaurs have been running away from an oncoming flood, caught up with that flood, and buried on top of the footprints. So, what you'd kind of expect. Michael did some really interesting research. If you look up the beds hypothesis, there's a very interesting idea about tides coming in and out during Noah's flood and redepositing sediment, which dinosaurs are then walking on and getting buried on top and kind of building it up in layers. And it really does seem to match what we find a lot of the time in these different footprint deposits around the world. So beds hypothesis is a good place if you want to look up some technicalities.
Joe, along those lines, the place that we actually went to and made the cast, there were 3 prints in a row. Then right next to it was a rock. I didn't show the pictures, but the gentleman said up until 1940s, there was a head of a dinosaur in the material. And then he said the Smithsonian came, took the bones, and you still get somewhat of a cast of what they extracted out of the rock right there. They said they've never seen it or received anything back from it. In other words, no money. They didn't get any money from it.
Basically, that's how you interpret that. Excuse me. Let's have another question.
Yeah, this is one for Glenn. So while we're still on Glenn and his footprints, is the story about Puxley River tracks true or false?
I assume this is the one in Texas with the human footprints, is what I'm guessing that they're talking about.
The Pulaski.
It's what?
The Pulaski River, isn't it?
Yeah, the Pluxy riverbeds.
Pluxy
river tracks.
Yes. And I'm no expert on that. Joe may know more about it than I do. I've understand it, kind of what Joe's talking about, that there were some in the Glen Rose area that you have dinosaur prints, and then those that they thought were human footprints. But with time, as more of the sediment was washed out, it became clear that the human footprints were not human footprints. And then since then, there was been some cases of what most people feel like was fraud with regards to the human footprint. So I'm not sure if that's the same location that they're asking about.
Yeah, it is with the Glen Rose, so the Polksy River Track. There's definitely very, very good dinosaur footprints there.
Yes.
You can go and still find there's new ones being exposed all the time, and it is the famous place where you supposedly found dinosaur footprints next to human footprints. Now, when the report of these first came out, basically nobody really knew about them. I mean, you can certainly fake a human footprint. It's not that difficult, but the original ones that came out before anything was collected or anything like that, and I speak as somebody, because John has shared with me, he was one of the first people to go out there and actually investigate it. And if you want John's testimony, the ones that he saw, he could not tell whether if they were fakes or not. Right? They certainly looked very real as far as what he could tell. Right? Now, that's not enough to determine whether they're real or not. There's all sorts of various tests that you could do, should do, so on and so forth. The problem was, by the time that John went out the second time to go and try and find them, number one, the amount of human footprints had tripled, right? Many of them very obviously carved because it had hit the media and hit the headlines and so on and so forth. Numbers of them had been cut out and carried off without any kind of proper research being done to them. Some had clearly been drawn on as well and chipped out. You could still see where ones had been drawn on, and we're now left in a bit of a mess, right? You've got some which are clearly dinosaur footprints that are deformed or eroded away, some with the original ones which may or may not be human footprints, but we've got no way of now determining them, and some which are clearly frauds, right? So you've got a big mess, and so the best thing to do is throw your hands up, walk away, and don't touch them, basically, right? You can't use them as conclusive evidence because too many frauds have been known and too much damage has been done, and reevaluation of any of the ones that are still in their original form have been pretty much shown to be sort of eroded dinosaur footprints, right? So is it possible? Yes. Is it provable? Not anymore. What should you do if you find a dinosaur and human footprint next to each other? Be very careful about who you tell. That's basically the summary.
Yeah, and we don't need those as evidence that dinosaurs were in existence at the same time as people, because there's much better proofs out there.
Yeah, exactly. Let's have one more question before we move on. I saw one about sea level. What's that one? There we are. Yeah, you got it. Yeah, lovely. How much would you need to lower the sea to make England, Scotland, Wales part of Ireland? The answer is... Well, the answer is a couple of 100 meters, which isn't a lot in the grand scheme of things. In fact, if I just pull up a graphic here, this is from, I believe the graphic is the Smithsonian's, but there is a lot of evidence that England, Scotland, Wales, and Ireland were all connected at one point. So hopefully you can see that tab there. What you can see is this big area called Doggerland, which is up in the North Sea, up here, okay? What you've got up here is basically where the North Sea is today. We know where the Dogger Bank is. There's lots and lots of fossils here. Lots of fossils get swept out from here and wash up along the east coast of the UK, particularly around here, around East Anglia and Norfolk. I grew up collecting, fossils that have been washed in. You have trawlers that go out, big fishing boats that go out and trawl the bottom to catch, shrimp and what we call prawns and the like, and crabs and whatnot. And they pull up huge huge mammoth fossils all the time. So we definitely know we find, stone tools that get washed out of there. We find settlements and so on and so forth. So we definitely know that this area was a land bridge at one point connecting what is modern day mainland Europe over into where modern day United Kingdom is. And you can see all of these rivers, right, which are flowing from the Highlands in the UK up here in Scotland and Wales, and what's around here in the Peak District and the Lake District, and they're all flowing out to sea up here in the Norwegian Trench. Now, we know this, but if you come have a look over here, what you can also see is as you have ice sheets during the Ice Age, biblical perspective, Ice Age is soon after Noah's flood, a few hundred years after Noah's flood, where you have warm ocean waters, you have very cool atmosphere, particularly around the poles, lots of aerosols and the like. So you've got the right conditions to evaporate lots of water from the sea and trap that water in ice up on the land, hence lowering the sea levels by 200 to 300 meters. If you do that, by the way, you could walk from the tip of South America to the bottom of Tasmania, but you'd have to go the long way round, all the way up through the Americas, across the Bering Strait, down through Europe, and all the way down to Australia, but you'd actually be able to do it. If you have a look over here, what's really interesting, if you can see my cursor, hopefully you can, you've got a couple of rivers, one which has its source up here from Scotland, basically down, one which has its source from Wales and the Lake District, and they join together down here and they flow out into the sea. Now, what's really interesting, we can still see the evidence of these two major rivers joining into one on the bottom of the Irish Sea today. You can do geomorphology scans of the bottom of the Irish Sea. It's still there. And what's really interesting is the Celts, right? The old Celtic tribes that lived in Ireland and Wales. They actually have stories of a time in the past when the giants used to live, when there were two rivers which connected Ireland and Wales, which meant you only had to cross two rivers in order to get over into Ireland. And it's rather interesting that we still find the evidence of those rivers today. The evidence tells us that there was a large land mass out there today, and you can still see the evidence of it when you go onto the bottom of the sea. And it's trapped not just in the science, if you like, and the sort of historical information from geology and geomorphology, but it's also there in the written and historical and oral records of the people that actually lived there at the time. So rather interesting to get it all into perspective. Let me finish that and come back. Hopefully that's good. Right, we've got a few more questions, but we'll come on to that a little bit later as well. But let's move on for now. We're going to go over to Diane because she's got a little report for us. We've recently had a newsletter out. That's right, Diane?
Yes. Last week we sent out our email newsletter. If you don't get that, it is free. You can sign up for it on our main website. But we've got a few interesting things that came up. We just keep a watching brief on the science news to see what's been reported out there to the general public, and we like to help people discern what we've already been talking about with these footprints. What is the actual evidence, and what is the interpretation of the evidence that is being presented? And it's important to be able to separate those two things, just like it's important what is the evidence with these footprints and what's the story that's being told about them. So if we go to my slides, we've just got a couple of interesting, we do all sorts of things in our newsletter, so you will see a great variety of things, whether it's biology, geology, human history, all sorts of things. So this was one story we found about a unique DNA repair protein that was found in a particular microbe which you may not have heard of, called Deinococcus radiodurans, and that name literally means tough, powerful, round bacterium. That's the coccus that resists radiation. And it is quite an extraordinary bacterium because it can tolerate amounts of radiation thousands of times more than what humans can. So much so, one article described it as Conan the bacterium. And if there was ever a nuclear war, if any of those terrorist regimes decided to get stuck into one another, well, Deinococcus radiodurans will inherit the earth along with a few cockroaches. Well, actually, we don't need to worry about that because the end of the world is solely in charge of our God and Father and the Lord Jesus Christ. But anyway, back to Deinococcus radiodurans. It's a common bacterium found in the environment. It doesn't seem to cause disease. It's actually quite friendly, likes to hang out in groups. But its distinctive feature is that it does resist higher doses of radiation. And so it has been studied extensively in terms of, well, how does this thing protect its DNA? Because if we could find out that, we could perhaps find ways of protecting our DNA. Now, it does have some what are called robust antioxidant systems. In other words, it is able to protect its DNA from being damaged by chemicals that are just the result of part of normal metabolic processes that happen in all cells. But the other interesting thing is that it has this amazingly efficient way of repairing DNA if it does get damaged. And that was the subject of this study. That's the name of their the paper that was put out. DDRC is the shorthand word name for this protein that they looked at. A unique DNA repair factor from D radiodurans. It senses and stabilizes DNA breaks through novel lesion recognition. Now, lesion just means damaged area, a lesion recognition mechanism. So what this thing does, it's a damage repair protein. It scans along the DNA strands looking for breaks. And if it finds one, it sort of snaps shut around the break, and that stops the break from doing further damage, from spreading along the DNA strand. And then it signals for the repair crew to come and fix it. It doesn't fix the DNA itself. It's the front line, as it were, to go out and find any damage and then call in the repair crew. And as the Phys, which is a science news site, its article commented that all cells do have DNA surveillance and repair process. We have them, all living cells have them, but there is a limited number of breaks that can be repaired with most DNA repair processes. But this particularly unique protein helps cells to repair hundreds of broken DNA fragments back into a coherent genome. So that's why it's important to study this and see if we can work out how it does this and perhaps apply it to genetic diseases. But that is also a reminder that, as they said, all cells do have surveillance and repair processes for their genome. That's going on all the time in all of your own cells. And the other interesting thing, of course, is that our cells are constantly dividing, and whenever DNA is copied, it is checked and edited during that processes. And all of these processes involve many proteins working together. As we often say at creation research, nothing in biology works on its own. So this is yet more evidence that DNA is not made for evolution. It's not made to be changed. DNA is designed for after their kind. So do have a look at that article and you'll find more details and specific references there. One of the other articles we recently looked at was about a study of the human heart. And we find these interesting headlines that go back to our point of what's the actual evidence, what are the beliefs and stories that are being promoted. So this was the headline of an article on a website called The Conversation, which has all sorts of interesting things, not just science, but politics and sociology and economics and other things. But anyway, they had science articles. What the unique shape of the human heart tells us about our evolution. Well, what's the story that they're trying to tell? They did a study of the structure and function of ape hearts. That's in living apes using an ultrasound method. If any of you have ever had an ultrasound scan of your heart, it's that sort of thing. So it's a non-invasive process where you can study a functioning active heart. And so they looked at the structure of ape hearts in baboons, gorillas, and chimpanzees, and compared those with the same structure and function of a human heart. Now, just a little reminder of the basic mammal heart structure, and our heart is that same basic structure where you have 4 chambers. They all work the same. And so you have input chambers at the top, which are the brown smooth chambers there, and then the output chambers, which are thick muscular chambers that actually push the blood out. And in particular, they were studying the left ventricle, so the main output pump that sends the blood out to your body organs. And the flow of blood is that it comes in from the top there, past this valve which shuts when the chamber contracts, and then the blood is projected out through a great big artery at the top of the heart. So there's that constant one-way flow like that, and it's controlled by valves to keep it one way. But you have this very, very thick muscular wall. Now notice that the wall is not smooth. It has a whole lot of ridges on it. Now those are bundles of muscles, and rejoiced in the name of trabeculae. And so what they were doing with this study was to have a close look at the pattern and the number of those trabeculae, those ridges, and see how they change when the heart is actually moving. And you can actually, with specialized ultrasound scan, see the movement of these muscle bundles, as well as study the internal surface and the internal shape of the heart. So what you're looking at here is if you've taken a cross section through this region, through the left ventricle there, towards the apex of the heart. So you've got orangutan gorilla, bonobo, which is a type of chimpanzee, rainforest chimpanzee, common chimpanzee, and then the human heart. Now notice that the human heart has a much more smooth sort of inner surface compared with all of these other ones. And what they found was that in the human heart, it wasn't just sort of squeezing in with the chamber getting smaller. You could actually see the action of the muscle bundles, and you had a sort of twisting and wringing action, which was particularly efficient for the blood flow. And so this was their conclusion, written by one of the scientists. We believe the human heart evolved away from the trabeculated structure, right? That's ridge structure seen in other great apes. Now, notice they assume that human beings are just another great ape, right? Seen in other great apes to enhance its ability to twist and contract more efficiently. And they then went on to say, our research challenges the assumption that heart structure is uniform across mammals. Instead, subtle but crucial differences in heart anatomy and function have emerged, right, in response to unique environmental challenges. So there is their story. They have found that the human heart is different to ape hearts, and so they've come up with this story. And we are entitled to ask questions of what their observations are compared with what their story is. Now, here are their actual observations. They did find that ape and human hearts were different, and they found that the human heart works well to meet the needs of the body. Now, the needs of the body that they're particularly interested in is that we have a very large brain, which needs a lot of blood flow through it because it's very, very metabolically active. And we walk in an upright fashion that other apes do not walk. Now, some apes can walk upright for a short distance, but normally when they walk, their brain and their body are more or less in line because they do walk on 4 limbs. So the standard evolutionary story, of course, is that human beings are simply the great ape that got up and walked, or the ape that stood up. And so we need to ask questions politely, but we do need to ask, all right, how are environmental changes going to change the structure of an ape heart? What's going to happen? Right, that's what they believe. Our belief about the origin of the heart is a belief. We weren't there when the human heart was created. However, our belief is based on evidence that the human heart works well. Therefore, it is a very logical belief to say that human hearts are designed by the Creator who made the entire body. So we can walk long distances. The standard evolutionary story is that being able to walk long distances evolved from what they call persistence hunting. When apes decided they didn't want to sit round in trees, but they wanted to go down on the ground and chase after prey, well, they had to learn to walk or run long distances. Human beings can do that, but our hearts are designed by a Creator who made the whole body. Again, nothing in biology works in isolation. The human heart serves its purpose because we can walk long distances, and we have a big brain which is directly above our heart when we are walking long distances. So do have a look at that. And then finally, we always like to see if we can find some interesting little design stories. And this one was about bumblebees doing a bit of head banging, which I believe is a sort of disco dance technique where you rapidly shake your head to try and stir up your brain. And it sounds awful to me, but anyway, it is called head banging, and it was referred to in one of the articles we looked at. So it's all about vibrations, and to do with a type of plant called buzz-pollinated flowers. Now, these are flowers that have their pollen concealed in sort of long tubular structures in the anthers, the pollen-bearing structure inside a flower. And in buzz-pollinated flowers, you can actually shake out the pollen by rapid vibrations, and the pollen is be released. And you can actually do that. You can fake this by using a tuning fork to release the pollen from one of these flowers, but the pollen just doesn't blow away. It's concealed in these long tubes, and the anthers need to be rapidly shaken. And so that's what bumblebees are very good at this. Honeybees don't do it, but bumblebees do this. But it's not just the sound of the bumblebee approaching through flapping its wings. The bees actually land on the flowers, and the buzzing noise comes from contraction of the what are called the indirect flight muscles. That's flight muscles in their thorax. And because they have this really clever hinge mechanism in their thorax, the muscles can be decoupled from the wings so that the muscles can vibrate, make that noise without actually flapping the wings. It's really, really clever. And we've known about this for a while. But the other interesting observation is that they do actually hold onto the anthers with their legs, and some bees actually grip the anthers with their mandibles or their jaws. And so some scientists decided they'd study this in a little bit more detail. And this is what they found when the bees grab the anthers with their mandibles or their jaws. They're also shaking their head at a mind-numbingly fast rate, accelerating several hundred times faster than accelerating due to gravity. So the buzz actually comes from rapidly shaking their heads as well as their thorax. And when they do this, they actually get better vibrations by using their jaws to grasp the anthers, and that means more vibrations and more pollen is released. And one of the scientists said, well, we're still learning about pollination. We've been studying for hundreds of years. It's amazing what we keep on learning. But it does bring up some questions that, again, we can carefully and politely ask the evolutionists. After all, answering questions by asking questions is a technique that Jesus himself used. You then have to go on and answer your own questions, but we are entitled to ask, well, how did the bees develop the muscle and the nervous system control in order to do this and to get the right vibrations? Because you, as I said, honeybees don't do this, but other species of bees do, including some of the little native bees in Australia. Why did the plants develop tubular anthers, and how did they do that? But most importantly, how did they both develop these things together within one generation? Because you've got to get it right straight away. A better solution for these observations is that God created fully formed plants with their fully formed functional pollinators, right, within 2 days of one another. If you go back and read Genesis 1 and the 6 days of creation. So those are some items in our newsletter. We do actually store them all in our fact files, so you can search for them as individual items. You don't need to know when the newsletter was sent out. We also have a couple of new questions on our Ask site. That's our question and answer site called Ask John Mackay. One was about post-flood Australian animals. Someone wrote in and asked, well, how did Australian animals walk to Noah's Ark? And then how did they get back again? We have a previous question on this. And in particular, they asked about penguins. I'm not quite sure why they picked on penguins, but we do have penguins in Australia, all along particularly the southern coast, but up along the east and west coasts as well. And this was a comment made by the person who wrote in with this question. A penguin, for example, could not survive in hot climates. The same would go for animals adapted to hot climates passing through areas with cold climates. So what they were saying is, how can we account for all the animals that got off Noah's Ark and had to go back to where they came from? So we do have to ask a couple of questions in response. Did Australia actually exist before Noah's flood? And where do penguins live now? I'll leave you to think about where Australia existed before Noah's flood. But where do penguins live now? Well, in fact, they live all over the world, south of the equator. So some of them live quite close to the equator. So it's quite possible for penguins to migrate through some fairly warm places. And some of them still live in fairly warm places like the Galapagos Islands. And along the Australian coastlines and South African and South American. And another new question we got was about Darwin, asking, can you supply me with references and links to Darwin being racist? Now that's a hot topic at the moment. This questioner asked, and do we have any comments about Aboriginals being the most primitive of all humans? Now, you probably don't realise this. Darwin did visit Australia in 1836 as part of the voyage of the Beagle, and he did see some Aboriginals, and he made a few comments about them. He referred to them as savages. And so this is what he wrote in his diary. It is very curious thus to see in the midst of civilized people a set of harmless savages wandering around without knowing where they shall sleep at night and gaining their livelihood by hunting in the woods. He then went on to describe them meeting some Aboriginals, and they persuaded the Aborigines to throw spears for them. Some of them were able to speak English, so they had a bit of a chat with them. And Darwin writes, in their own arts, they are admirable. They will not, however, cultivate the ground or build houses or remain stationary or even take the trouble of tending a flock of sheep when given to them. On the whole, they appear to me to stand a few degrees higher in the scale of civilization than the Fuegans. Well, who are the Fuegans? In fact, they were the people that he saw in Tierra del Fuego, which is at the bottom tip of South America. And he described them as living in fairly squalid conditions. And after he came back from his trip around the world, Darwin did actually donate to a South American missionary society, not so much because he wanted the gospel to be spread. He didn't. He was not a Christian, but he thought that missionaries had a civilizing effect on people. So again, there's that division in his mind between civilization and savages. He was reflecting in 1836 just the general views of what 19th century English people did. But by the time we got to writing The Descent of Man, which is his other famous book, right, his evolutionary worldview was thoroughly embedded in his mind. His whole idea that there's this great organic chain, great chain of being between man and the lower animals, but there has to be a physical connection there. The fossil record does not show that, nor does the living world, and so Darwin is trying to explain these gaps in both the fossil record and the living world away. And so he says the great break in the organic chain between man and his nearest allies, which cannot be bridged by any extinct or living species, he then he writes in very florid language, so he then goes off on a little diversion and then comes back to his conclusion. These breaks depend merely on the number of related forms which have become extinct. So the gaps are simply the result of some things living and dying out. And so what we see are the gaps, or the things that are on either side of that gap left by extinct creatures. And he then goes on and makes this comment. At some future period, not very distant as measured by centuries, the civilized races of man will almost certainly exterminate and replace throughout the world the savage races. Now, we've seen him refer to the Aborigines as the savage races. So in Darwin's future history of the world, the civilized races would exterminate the savage races. Now, this is evolution in action that is quite consistent with his worldview of the struggle for life, survival of the fittest. And so it's really important that Christians understand and we need to abandon any sort of romantic ideas about evolution being some sort of glorious unfolding of life or anything like that. It is a really ugly, nasty process if it did really happen that way. Then he comments that some ape-like creatures, as this particular German professor, will no doubt be exterminated. So the end result of that in Darwin's mind is that the break will then be rendered wider. Okay, so some of the ape-like creatures between human beings and apes will have died out, and more on either side of the gap will be wiped out. So the break will be rendered wider, for it will intervene between man in a more civilized state, as we may hope then the Caucasians. Right, so the gap is going to get bigger so that we'll have Caucasians on one side, apes as low as baboons, so baboons on the other side, and in between that, the ones that are in between will be eliminated. Now notice what he puts in between that gap, Australians and gorillas. We do have references and links to all these original writings, which you can look up. So have a look at the fact file and the Ask site, and you will find more details with references and links to all of these stories, the Science News stories and the new questions. So if we can come back to us, if anyone else wants to make any more comments about what we've said and what we have on our website. Just in relation to Aborigines, if any of you are living in the Brisbane area or have access to it, we are having an open day at our Brisbane Museum fairly soon, and you can come along and see our expanded display on Aborigines, their origin and their artefacts. And we have some wonderful new artefacts that have been donated to us from the Aborigines, so it's all legal. We can display them, and you'll learn some interesting things about where the Aborigines really fit in the history of the world, and where they really fit into biblical history as well. Yes, thank you for putting up that.
Yeah, John made me promise him that if he wasn't able to come tonight, that we would definitely promote the open day. So thank you, Diane, because I had almost forgotten. But yes, it's 28th and 29th of September. You must book, but it is free. So you can go to creationresearch.net and there's a great big graphic that comes up telling you all about it, or you can go to creationresearch.net/open day and there's all information about that online as to what you need to do, where you need to go, and how you need to get in touch and book. And I believe, Diane, you're going up there ahead to set up the Lucy display as well.
Yes, I will be there. So I look forward to meeting some of you. That would be really good.
Good stuff. Great stuff. Well, we've got about 10 minutes left for some Q&A. And if there are any other thank yous to cover those as well. So let me just take that down. And we've really just got about 10 minutes left just to cover one or two quick things. So let's have a look and see how we're doing. How are we doing over in the chat, Steve?
Yeah, we've got some questions there. One that's probably most related to Diane's sharing before, just recently. Do we know which chimps, etc., are part of the same kind, and which are different kinds?
Well, chimpanzees are classified as pan, P-A-N, is their genus name. So the common chimpanzee that we mostly know about is Pan troglodytes. The rainforest chimpanzee, or the bonobo, is a small group of chimpanzees that only live in one section of Africa. They are smaller and more finely built than the common chimpanzee, but they are of the same kind. Obviously, this is a population that's simply become isolated, so those particular features have become embedded in it. So both the bonobos and the common chimpanzee, I would put in the same kind. There aren't all that many differences between them. And the genus name for both of them is Pan troglodytes and Pan paniscus.
And you also find as well that there are a good number of extinct apes as well. It seems like with every living thing, there is a wider diversity that is now extinct, right? Particularly coming off of the Ark, adapting very quickly to a very quickly changing world. And then as the world settles out into the extremes that we see today, a number of them going extinct and being unable to survive. So if you go to places where you find fossil apes, right, like in Africa, for instance, they don't have any apes living, or any sort of big apes living where you find the fossil ones. Well, there's one simple reason for that. A lot of it is now desert, right? And you can't survive there anymore. So you've got changing environments, which means that creatures die out. So like we were talking, and if you remember a few weeks back, a couple of months back, we did our Lucy program, right? And we had that kind of set up, and we were talking with Diane when she was here in the UK about the fact that Australopithecus just means southern ape. So we're dealing with one of these extinct apes, certainly in the same kind of kind and grouping as many of the modern apes today, but now extinct in its sort of, its nuances of species. So you've got to bear in mind as well that the world has changed, God has not, and creatures have certainly gone extinct within a kind that we don't have anymore. There's a good quick question. Have any ape fossils been found in Australia? I don't think so.
None. Only the ones that have been imported.
Yeah. No, I don't think anything's been found in Australia. Right, we've got about time for about one more question. Let's have a quick look and see what else we've got in the questions. That question about cancer related to I think what Diane was talking about a little bit earlier. Any comments on this from a biomedical point of view, Diane? Could green foods be the cure for cancer? God gave us green foods, not bacon and steak.
Well, green foods, I presume you mean vegetables, not green foods in the political greeny sense. Sadly, no. Cancer is the result of DNA not being repaired, and that actually happens from processes within our own cells, but also from external radiation and chemicals and things which are part of the fallen world that we live in now. So in the beginning, yes, there was no cancer. That's because God created everything very good. So human bodies were very good. The environment was very good and protected. And since then, it's gone downhill. Green foods are very good for you because they contain the right sort of minerals and vitamins as well as nutrients. But in between the world becoming corrupt and God judging it, and then where we are living now, there is one place where God did give us permission to eat bacon and steak. He doesn't say that we have to, but he did give permission after Noah's flood for people to eat animals if they live in an environment where you cannot get green foods all through the year, like some of those very cold places and some of those desert places that we have mentioned in tonight's program. So yes, sadly, no diet is a complete cure for cancer because the causes of cancer are things that we can't control anymore. But eating a good diet is certainly a good way of keeping healthy.
I think that's something which isn't discussed as much as it should be with amongst the sort of a lot of medical professionals nowadays. A lot of it is solutions to problems rather than preventing the cause in the first place, right? If you are going to be obese, then you are more likely to be susceptible to things breaking down and going wrong. If you are ingesting toxins of some form, don't be surprised if things break down later on and quicker later on as well. But you've also got to remember there was a fad going around a few years back of effectively the argument was, well, God created us to eat 100% raw vegan diets. Therefore, if we all eat 100% raw vegan diets, none of us will ever get ill. I appreciate the sentiment. The practicality side of that is, of course, we're not living in a perfect world anymore. We may have been created for that, but we're living in a world that is now corrupted and marked by sin. And as a result of that, we've gone downhill and our bodies are no longer able to digest as well as they used to. And the plants have gone downhill and have no longer been able to digest as well as they used to. And, even some plants are toxic and poisonous and so on and so forth. So you do have to be very careful with that argument. But the good news is that in the new heavens and the new earth, we'll be able to feast not only on fruits and vegetables, but also on the tree of life, which is a wonderful promise that we have there as well. Well, that brings us just about to the end of our time tonight, and we'll be back, of course, next week with the Creation Research team as we delve into another topic. Hopefully we will have John back with us there as well, which will be great, and we'll be able to carry on discussing. And I think at some point, it's been a few weeks now since we've had a Q&A special, so I think at some point we're due a Q&A special, because we do have some questions that we didn't quite get to tonight, and we've got some questions from previous streams, so do be prepared for that. It may well be a Q&A special next week as we try and develop Creation Conversations out a little bit more. We've had a little bit of a rearrange and a rejig around in the last few weeks, so we're still working on it, and we will be back next week with another program. Any last comments from the team before we close?
Just that all God's creatures just exhibit amazing design, and all that design has to be there in place from the beginning. And this week has been a reminder of that, as I'm looking at you with much lower power glasses, because doctors went in and took the lens out. Now, if they hadn't put a new lens in, I wouldn't be able to see you at all. Everything in the eye had to be in place at the same time. It couldn't evolve one component and leave the lens out. But they gave me new lenses, and I can see you a lot better today.
Good stuff. All right, folks. Goodbye. God bless. We will see you next week as we carry on with Creation Conversations. See you all later, everyone.
Yes.